Imagine a weapon so gargantuan it couldn't roll down an ordinary road, a machine that required its own custom-built railway system and demanded an entire military operation just to reach the battlefield. This was the Schwerer Gustav. Produced by Nazi Germany during World War II, it remains one of the largest artillery pieces ever constructed. This diagram of the main gun barrel illustrates its scale. Stretching roughly 32 meters long, it makes a standard human silhouette look like a toy. And the total weight of the completed weapon system clocked in well over 1,000 tons. These metrics pushed the Gustav past the boundaries of conventional artillery. Krupp was essentially building a piece of industrial architecture that tested the material limits of 1940s engineering. The German company Krupp developed this behemoth to solve a very specific tactical problem. The military wanted the ability to obliterate heavily fortified enemy defensive structures with a single, overwhelming strike. Krupp's solution was an immense 800mm caliber weapon designed to fire some of the largest, heaviest artillery shells ever used in combat. But by designing the ultimate static bunker buster, they created a machine that directly fought against the most crucial elements of modern warfare: speed and mobility. The theoretical limits of that design met reality during its most famous deployment at the Siege of Sevastopol in 1942. You couldn't simply drive a 1,000-ton gun to the front lines. The Gustav had to be manufactured as a collection of separate, massive industrial components and shipped in disconnected sections. Before the gun could even arrive at Sevastopol, engineers had to carve out the terrain and lay down specially prepared custom railway tracks at the designated firing site. As this flowchart shows, the system required a staggering support organization just to fire a single shell. You needed railway crews, engineers, mechanics, and artillery specialists working in unison. Because it was completely immobile, an enormous security detail formed a wide perimeter to protect the asset. Deploying the Gustav demanded a level of resources usually reserved for an entire campaign, siphoning manpower and logistics away from the rest of the front. When it finally fired at Sevastopol, the weapon did exactly what it was designed to do. Its 800mm shells punched deep through reinforced Soviet defensive structures before detonating. The raw, localized, destructive capability of those massive rounds was undeniable. Yet, that brute force success was offset by the grueling reality of actually operating artillery at this scale. Even moving a standard artillery piece required immense physical labor and mechanical friction. Scaling that up to a 1,000-ton railway gun meant that loading, aiming, and repositioning the Gustav took agonizing amounts of time and effort. It became a case study in diminishing returns. The overwhelming logistical paralysis required to transport and assemble the gun effectively neutralized the tactical advantage its firepower provided. The Gustav was also a massive defensive liability. Its oversized silhouette made concealment from enemy aerial reconnaissance nearly impossible. Beyond its tactical vulnerability, the financial and temporal costs were crippling. It took incredible sums of money to manufacture and weeks of setup for a single battle. Because of these immense drawbacks, only a tiny handful of these super-heavy guns were ever constructed. The very engineering features that allowed it to shatter bunkers, its extreme mass and weight, were the exact flaws that limited its use as a practical weapon. By the middle of the 20th century, the static nature of railway guns had become a liability in a world prioritizing nimble, adaptable military technology. The battlefield was shifting toward aircraft and self-propelled mobile artillery, which could strike targets much faster without dragging thousands of tons of logistical baggage behind them. The rapid rise of rocketry offered a cheaper, highly mobile alternative that could deliver substantial firepower and relocate before the enemy could even react. Today, the Schwerer Gustav's legacy is a technical one. It remains an imposing symbol of what happens when mechanical engineering is pushed to an almost unbelievable scale. But as a tool of war, it left behind a definitive lesson. Flexibility and mobility will reliably outmaneuver sheer, static destructive power.